I actually really like this problem. Let's start off with this one. We're going to do the reverse. What we've been asking you is we've been giving you an equation and we say from that equation, figure out all of these information. In this way, what I'm going to do is I'm going to say, here's all the information, give me the equation that came from. Alright, let's graph this first. This thing has a vertical asymptote at -3 and +1. Okay, so +3 and -1. This thing has a intercept at x equals 1 and x equals 2. So 1 and 2. Interesting. This has a y-intercept is positive. This also has a horizontal asymptote at -1. How does that graph look? Alright. The y-intercept is positive. What can that graph look like in order for this thing to work? Okay. I would say that this thing probably has to come down like this. Then I would say that this thing jumps across here like that, and jumps across here like that. Interesting. I'll tell you what, why don't we try to plug this into an equation, then we'll graph that equation and see if that has all of these properties. Alright, I know it's going to be a fraction. I know the denominators is going to give me my vertical asymptotes, so that would be at x plus 1 and at x minus 3. And you guys are thinking, wait, that's opposite of what you have. And I say, yeah, because if I figure out what the vertical asymptotes of these, that would say x cannot equal -1, and x cannot equal to 3, which is what my vertical asymptotes are implying. I can say that this thing only has x-intercepts at 1 and 2. So I'm going to say that this implies that x minus 1 and x minus 2 is my numerator, because when I set that equal to 0, that would give me x equals 1 and x equals 2. I would say the horizontal asymptote is -1. Let's see. That would mean that there should just straight up be a negative out in front here. Because when I look at x going to infinity, that would be x squared on top and x squared on the bottom. That gives me a positive 1, but I want the answer to be negative, so I put a negative out in front, so that'd be -1. So, and the y-intercept is positive. So if I set x equal to 0 on all of these, am I going to get a positive y-intercept? That would be, let's see, -1 minus 2, or not minus 2, but times -2, over 1 times -3, and there's a negative out in front, so then I have -2 on top and -3 on the bottom. That would be 2/3. Hey, that's a positive intercept. I'll tell you what, why don't I graph this function right here and see if I get, if it has those properties. Negative x minus 1, x minus 2, x plus 1, x minus 3. All right. X minus 1, x minus 2, x plus 1, x minus 3, negative. Yep, isn't that what I graphed? That's almost exactly what I graphed. It's kind of like that. The gray thing, right? It's exactly like what I did. Dude, I'm so good. I'm so smart. Anyway, that's kind of what's going on there.